boils down to chief technical guy. I like the introduction better than architect. I used to hack on the Apache web server a lot, but everyone switched to Nginx, so oh well. I used to also do a lot of work with Apache with the infrastructure of the foundation. So running the actual www.apache.org, and someone conned me into being the VP there for a while. We convinced Philip, who's in the audience, actually to do that now. He's the current VP. But important for this talk is Libcloud, and I like to hack on that project. Let's talk about the cloud. It's exciting. It's kind of an overloaded buzzword. It's really awesome. You go to these conferences and it's great. It changes the universe. Not really. I mean, sometimes it's cool, but sometimes it really sucks. But mostly it's a good thing. It's a good innovation on a lot of models. So I'm going to talk about computing. Amazon EC2 is the most popular, but there's lots of alternatives. Not about, calling Gmail a cloud service or anything like that, or cloud storage. There's always different cloud things, but we're just going to talk about computers, because that's what most people care about. So what this is really about is changing the model of how you get a server. Right? You used to call Dell, and they'll say, well, we'll sell you the server for $14,000, and they'll ship it in a UPS crate or a pallet, depending on the volume. Not even UPS at that point. And then some lucky guy gets to go to a data center and rack it. And that's, traditional, you own the servers, you put them there type model. And that's over. What this is all about is I want a server right now, you flip a switch and it's on. So that's where Libcloud gets involved. Libcloud fundamentally is a Python library to talk to these different cloud providers. This is a simple example. We're talking a rack space, and we're booting a server. And now you have a server on rack space. And it's nearly the same code to talk to EC2 or anywhere else. And this is just a fundamental shift in how you even allocate resources. It lets you be dynamic. You don't have to, you should capacity plan, but you don't have to capacity plan 6 months out on what your purchase order is going to be. You have to capacity plan for other reasons. So Libcloud was started about a year, or more than a year ago now, as a easy-to-use and portable library. Because what we found was people started writing these little utility scripts to hit EC2's API, and they're all just kind of this conglomerate of bash scripts that are calling a Java jar file that goes off and hits EC2, and then they extract out some metadata. And they weren't really a good way of talking to these cloud providers. So what we focused on with Libcloud was, let's make it really easy to use. Let's make really simple APIs that are easy to get data out of, and let's make it a fun little project. And so it's actually not that much code. It's only a couple thousand lines of Python total. And it works, and it talks to different cloud providers. Some Java people, since this is an Apache project, some Java people said, hey, we really like this idea of this simple API. Let's make a Java version of it. So there's people working on a Java version now as well. But I'm not going to talk about that too much. So, the first question you'd ask is, well, what's wrong with all these bash scripts that call a Java jar, that extract metadata? Well, the biggest problem is all these different APIs have completely different ways of talking about their servers. Amazon uses XML with custom HBAC authentication. Rackspaces uses JSON plus these authentication tokens you have to pass around and get from an authentication server. Software uses XML RPC. Why? No one really knows, but they do. And so just even talking to someone about, I want a server right now, is a difficult thing because there's no decided standard on how you talk to them. But they all just made up their own API. And so we needed something that lived there in the middle and really, mediate between them. Libcloud today has 17 providers. Basically, anywhere you could get a server, from a VPS to a cloud type thing, pretty much Libcloud can talk to. And if it doesn't, it's usually pretty easy to add it. We've made enough abstractions, enough generic code now that some of these drivers are 40 lines long of, yes, this is where the data comes from type thing. So if there's a provider you like that's not on here, you should probably submit a patch and it'll get in there pretty easily. So Libcloud fundamentally started around six core APIs, things that we thought were portable between all these different clouds. It started with listing the nodes. I mean, where are your servers? Then list images, which is, can you make an Ubuntu machine or a Fedora machine, all those type things. List sizes, which is, is it a 1 gigabyte of RAM and 200 gigs of disk, all those type of abstractions. And then create, destroy, and reboot, just CRUD operations, basically. And it's not that much, but it allows you to do a lot later on. So here's the simple example code of list nodes. It's a Python code, but it's pretty simple. And how we started using it is, you take list nodes and then you build on top of that to do other things with other libraries, even executing shell scripts sometimes. But we're starting with this programmatic model of talking about your servers. So we found those pretty quickly, those 6 APIs couldn't really express everything you wanted to do, especially on Amazon, where there were a lot of extra things. So we have a lot of extended APIs, and they're documented with the EX prefix, and they find it all over the different libraries. A simple example is Amazon security groups. If you've ever used Amazon EC2 a lot, you found that you need to either create a security group, put everything in it, or, because they do like port firewall restrictions by default on all of your servers. So you have to decide what security group to put in. So we put a lot of extended APIs in there to actually make it useful. So getting started with cloud is really easy. It's just a Python module. You do easy install Apache Libcloud. Getting your provider info is probably a little harder. Amazon makes it actually relatively easy. It's in their portal. You can click on it, get your AWS credentials. Rackspace is actually hidden behind like the settings panel, actually really hard to find. Most other providers, their API keys are hidden somewhere in their control panel, somewhere if you're lucky. Others you have to ask them for it. So again, here's an example of listing your machines. We asked the cloud for the driver for Rackspace. We're iterating those nodes, printing their ID, which is like the provider ID. So in Amazon, it's that cute name for the machine, like I3415A, that you can never remember. The name is a name associated with the machine. Other providers besides Amazon actually let you rename your nodes. It's a crazy idea. And then, we also include all the metadata about the machines, like their public IP address. And this is where you can start doing more creative things with it. One thing I do want to talk about, though, is one feature we included in here was the location of where the server is getting booted. And we also included the price per hour to run them. So now you can start building things on top of Libcloud that are finding the cheapest machine with 4 gigabytes of RAM that's outside the United States. Now that's a contrived example. Usually you don't want to find something outside the United States. Usually you want to find something either like in the European Union, for example, if you have restrictions on where your data can be. But you're starting to move away from going to someone's pricing plan page and looking at what the current prices are every few months and saying, oh, well, let's move over to this other provider. Everything's API driven. You're making the decision, I need a new node, well, let's find the cheapest one. And you're not looking for pricing, it's just there as part of the API. So this is the actual code in Libcloud that will go out, find the cheapest node somewhere, boot it, and you're there. And like you have a server somewhere on the internet that is cheaper than if you just bought it from Amazon, for example. So you have a list of drivers. I mean, this is a compact example because we use filters and lambdas to try to make the code shorter. But I mean, basically, you just find all the possible locations, find the ones in the US, find all the different server sizes, find all the big ones, and then you sort it by price. And this type of thing is pretty much impossible if you were just using a battling. You could write a bash script and talk to 12 providers, but it's really hard. And so Libcloud is something that you build on top a higher level view of how you manage your servers. So one more thing that this API, I said we started with like 6 APIs and a few extended APIs, and we found that just booting a node somewhere didn't get you very far. We found that providers, some of them, like Amazon, let you choose an AMI and you boot this AMI and you customize it and you get your key pair. Others literally, boot a single image type. If they only boot CentOS, and they set the root password for you. And now your script needs to deal with all these complexities of, well, I just want to SSH into the machine. So what we built is an abstraction on all this that works on all different providers called deploy node. And it takes care of getting you that first shell on the machine. So here's a simple example of where we're going to boot a machine, we're going to add a SSH key, and then we're going to apt-get install Puppet on boot up. And how this is written with deploy node is this will work on Amazon or Rackspace or Linode or any of these other guys, because they all have different abstractions. I mean, Amazon, they give you SSH keys, and they're very strict about that. But like Rackspace, the API call that you make when you create the node returns you the root password, and you have no other way of getting on the machine other than this root password. So, it's really providing that kind of, the SSH key deployment is a good example where you give it the SSH key, and now we install that SSH key if we need to. If the provider only supports password auth, we SSH in and do it for you, and then you can keep going with the rest of your scripts that use SSH keys. So what I want to get more into, though, is changing how you do your operations. And Libcloud is really an enabler for that. Traditionally, we've seen a lot of enterprises is these same bash scripts that I complain about for running EC2 commands. A lot of people have that for doing anything with their servers. They have a big variable at the top that has, here's all our web servers, here's all our database servers, and then they'll script things against that. What Libcloud allows you to do, instead of maintaining this metadata in some central repository, you just ask the provider what's actually running out there. So this is the simplest example of working with Fabric. And so Fabric is similar to Capistrano, if you're familiar with that. It's basically a set of Python tools for scripting against servers. It has a very simple model. It deals with the SSH part and running things on remote servers. So in this example, we're populating the host list, the lists of hosts that Fabric's going to run against a Libcloud list of public IPs. So it allows you to do things like, when you boot a server, it's automatically included in your scripts instead of someone having to update somewhere in a central repository. This example lets you run the hostname command across all your machines in Libcloud. So this is the output of that simple command is it goes out and runs hostname and shows you the output across any number of machines. And so if I booted 5 more machines, it would all just show up next time I run the fab command. And so this is changing how you do, you need to look at servers as resources. I mean, programmers have treated things as resources for a long time, that they just make an API call and magically it's there. And servers are turning into the same thing. And operations, there's this, I don't know if I'll call it a fad, a thing called DevOps, where people are talking about operations in terms of developers, and that you're scripting things, that you're not, you're writing code to talk about your servers. So Libcloud is interesting in that it gives us this nice baseline of things to do with servers. But what we found was that wasn't that interesting. Most people can create servers, and that's not that exciting. You can create a server, yay. So what's really up for next for Libcloud are things built on top of Libcloud. So there's 2 I want to talk about here in a little more depth, and one is server lining. It's a Python deployment system built on top of Libcloud that lets you basically, you can boot a web server, it'll install Apache with ModWizG, and you start from your source directory, say, server lining upload foo, and it will package up your app, boot a server for it, upload your app, install ModWizG, and run your app. So now your little Python Django web app, instead of having to, ask an operations guy to boot a server for you, and then a few days later you get a server and you go in and you upload your app and do it all manually. Even if you're using configuration management with Puppet or Chef, you're still reacting to those. I mean, Puppet and Chef's model is fundamentally about taking a pristine state and making a server look like that, which is a good thing. You should do that. You should still do that even with all this cloud stuff. But server line is kind of changing that a little bit. It lets you build an app out and get it going very quickly. Pantheon Mercury is a similar project, but it's focused on PHP and Drupal. So you basically can, boot an entire Drupal cluster, including like Memcache servers, MySQL servers, Nginx caching layers. They have it all scripted using Libcloud, so that you press go on the command line and it does all this stuff for you. You're not spending time changing configurations in different places or anything else. You just press go and you have an entire cluster with all the right things done for you, like all the caching and all that. So I do want to talk about something a little different. Libcloud and even like Pantheon and Silver Lining, are really still focused on the VMs and managing those VMs and installing things to those virtual machines. But we're starting to see, there's two ones I want to talk about specifically. One's called Cast. It's a project we're hacking on at CloudKick. Another is called Galaxy, which Ning just open sourced last week. And what they're both focused on is building out API-driven things for applications. So you define this way, instead of saying, I want a server with X on it, you say, I just want a MySQL server. And they take care of potentially creating a node somewhere with Libcloud, or and then booting it, getting the service actually installed. And so Galaxy specifically is focused on these use cases, which they have Java VMs and Apache nodes basically, and they're set up to create those instances very quickly. Cast is a newer project and is focused on being much more generic, but basically with Cast the goal is that you can take the Node.js app, bundle it all together, boot a server, and say, just put it up there. And it'll take care of service management, like starting, stopping the service health monitoring, making sure the service is actually running. And the interesting thing about both these is, instead of normally when you want to see if a service is running, you go and SSH to the machine. They're both moving this application management sphere, which is still usually restricted to someone logging into the machine and looking at it, into the same thing Libcloud did for servers, which is now it's API driven. Cast, for example, everything is a RESTful API in it. So if you want to restart a service, you just hit a REST API and you restart the service. And the same thing with like tailing a log file in Cast. You can actually tail a log file over HTTP and it'll stream it to you as you go. It's a Dirt application as an example, right? You're taking this data that's on a server and streaming it to you via an API. And you can do all this using a bunch of shell scripts. But there's not the same level of long-term maintainability, a series of bash scripts where you use SSH keys everywhere. With HTTP-based APIs, you actually really expose this data that previously was very hidden inside these apps. So that's where this is kind of going, is people are moving up the stack. Libcloud does give you that baseline, but it doesn't really help you run your app. It just helps you get a server somewhere and control that server. Whereas Cast and Galaxy are both projects working on kind of moving this to the next level, where you're doing operations on a server over HTTP. I do want to shout out to some related projects. One is called JClouds. It is very similar to Libcloud. It's all written in Java, which some people like because they like Java. And it provides a lot of similar abstractions. They have a similar deployment model, so it'll install the SSH key for you, all that type of stuff. People are using this even like on Google App Engine to provide some abstractions over platforms as a service, not just infrastructure as a service. The other one is Apache Delta Cloud, which is Ruby-based. It has some different ideas on how you talk to it. It actually creates a local web server with a REST interface, and then kind of proxies those calls out to different providers. It's a little different, but it's Ruby, and they're doing some cool stuff with it. Questions, I guess. Libcloud.org is where a lot of this code hangs out. Pound Libcloud on Freenode, and I have slides online. I think I went a little fast. Do you have any questions? Yeah.
How do you put the data center awareness on when I want to deploy, make the order look out?
So questions about data center awareness. basically, deploy to a particular locality.
Yeah, I want from geo-awareness to where I'm deploying.
Okay, so in Libcloud specifically, we actually keep track of all the physical locations of the data centers where your machine will be booted. So currently, we just keep country and state for US-based ones. So you can say, I want something in California. We talked about doing more creative things with latitude and longitude, so that you could actually calculate where your servers are located. But basically, when you call list locations in Libcloud, we figure out, some providers don't tell you, but we figure out where their data center is and hard code that in for them if they don't provide it with the API.
When you consider actually encoding latency then, because that's actually, I actually don't care where it's located.
Right. Yeah, I mean, if we had an easy way to say this is 200 milliseconds from this place, I would love to put that in the API. Because that's what, I mean, even, there's still, the reason we want a location, I think, for two purposes. One is latency, for latency issues. The other is for legal restrictions. And right now, there's just not a good way to programmatically tell you this place is on average 200 milliseconds away. But that would be a very interesting way. I would love to have that ability. So the question's about, is there an aggregator service to kind of take this data from the API and make a dashboard type thing? I don't want to do a product pitch, but that's what a lot of CloudKick does, the company I work for. And we built Libcloud to kind of power that. There's a few people who have made like a few command line tools and a few simple web UIs. There's a simple web UI in the contrib area of Libcloud that just lists your servers and basic stuff. But that's kind of a lot of what CloudKick does as a company.
Do you find that these providers tend to break their APIs or frequently?
Yeah, so the question's about providers breaking APIs. Amazon doesn't tend to. They're probably the highest quality as far as APIs go. A lot of the smaller providers do break them every now and then. But we have a big enough set of regression tests with Libcloud. We're usually pretty quick about detecting that. That's one thing about the internals of Libcloud is everything's actually pretty well tested. We have both hard-coded responses from what we expect the APIs to be and what they actually give us, and we compare them. So we have a pretty large test suite at this point inside Libcloud to detect that situation. And then even on the more commercial side, CloudKick, because we have enough customers, we're hitting these APIs a lot. So we usually see it very quickly. I'll see an error on Linode and then go talk to Jet at Linode and say, hey, you just broke something. So it happens. Amazon doesn't very often. Rackspace just has downtime problems with the API sometimes. They're hopefully getting better at that. But they're like any web service. They're evolving still a lot of them. Most of them are pretty good about versioning and not breaking it though, because most of them have paying customers, right? They're not going to purposely kick off all their paying customers from booting servers. So.
Where does Heroku fit into all this?
There's questions about Heroku. Where do they fit in? So there's kind of two classes kind of emerging of cloud providers, just on the compute side. There's ones that provide just bare metal servers with varying levels of support, and there's ones that are, people call it platform as a service, right? Where you're providing a platform to build upon. And Heroku definitely falls in that later category. You don't really, you can manage how many database servers you have or how many web nodes you have, but you're not really exposed to the internals nearly as much. You're not deciding where that server actually lives, or if it runs MySQL 4, MySQL 5, or any of that details are all taken away from you and you just dealt with. And so generally they're the premium because they're dealing with all those operational overhead for you. Heroku is in that genre. Even you can think Google App Engine is very similar in that genre where you're just given a web request, you upload data, you upload a Python script, and you get hit with a web request. And they take care of all the database backend. Well, not database, but all the data storage they take care of. So there's kind of those two classes emerging. One is very high level, you upload your code somewhere and they do everything for you. The other is you get a root login, do everything yourself. But you even see differentiation in that. Amazon, for example, is very hands-off. You'll be lucky even if you pay them a lot of money to be able to call someone on the phone. their answer would be, well, you should just boot another server somewhere else. They're very hands-off if anything breaks. Rackspace or all the other providers in my hand are, you call them on the phone and someone answers, and they're working with you to fix a problem. So there's a differentiation there on like the basic support and then on the high-level services. I mean, Heroku is interesting because they provide a lot of services. They're just going to have, I think, a hard time competing with like Google App Engine and some of the other larger services. What?
Any support currently in extensions for cloud storage for EBS?
Yeah, so the question about cloud storage, EBS. There are extended APIs to talk to create EBS blocks and do basic things with them, but it's not extensive inside Libcloud itself. And actually, I'm working on kind of revamping that right now. So you can create a couple of EBSs and say assign them to a server, but it doesn't maintain a lot of metadata around them. This is actually something that Amazon recently changed. They added tagging to their API, so you can tag things to different values. And actually what I want to do with EBSs is say, tag them to a machine name, so you can actually keep, these 10 EBSs are an RAID 0 on this machine, and keep that metadata in the Amazon API, whereas today you pretty much have to have your own kind of metadata store that keeps track of what all the EBS is actually doing. So there's basic support for it right now, but it's definitely something we're going to keep expanding, I think, in Libcloud.
Is there any desire within Libcloud to do like cost projection and so forth? It's really easy to like spin up 20 64 gig nodes in Amazon, but at the end of the month, and they're not going to stop you. But at the end of the month, you're going to get a 20 grand bill. It's like, whoa.
Yeah, so the question about cost prediction. So I mean, the first thing Libcloud does is we actually include the pricing of each node in the APIs, in the Libcloud APIs. You can say, how much is that 64 gig node actually costing me? And in Amazon's case, actually, this is a pain. They don't have any way to tell you the API. You have to go to some web page and look at what the actual prices are. So we actually, whenever they change that pricing page, we change code in Libcloud right now, which is frustrating. They should just have an API where you can ask how expensive a machine is. So at least with Libcloud, you can script the cost. You can have a script that says, this is actually costing me X a month. There are some things in the commercial cloud side we do where we can make the prediction graph of where your costs will be, that type of thing. But that's not really in Libcloud itself. But Libcloud gives you the tools to at least know what you're spending. Because you can ask it, how much is this server actually costing me?
And just one other question.
Yeah.
For kicks and giggles, is it possible to do like, say, an LS and get back a list of all the available node types spread across all the different vendors?
Yeah. Yep. I mean, it's you just iterate the list of drivers and ask them for all the node sizes, and it should return. It's actually a pretty quick call to do that type of thing. I mean, and we've done some more creative things, even like list notes I didn't even get into. Is like we have a script that maps all of our servers every day and looks for problems, because it was easy in the old world where you set a central metadata information somewhere, usually most companies do, whether it's a wiki or an actual programmatic way of doing it. But then someone will boot a rogue server and you didn't even know about. But now we can kind of detect those type of things and say, well, why is this server up? Why is it running Apache? Or all those type of things you can start doing that you couldn't even get to before.
Just seeing the Python syntax maybe JavaScript. Is there any plans that move this into Node or whatever any other server-side JavaScript?
It might happen. I'm involved a lot with the Node community, and even inside CloudKick, we're starting to build apps on top of Node.js. So there is someone's written a Rackspace binding for Node.js. I think there's an EC2 one as well, but it might just happen that we port Libcloud to Node.js. It fits in really well overall, because Node is doing HTTP. The only painful thing with doing XML parsing, we'd have to pull in the library probably. But yeah, I would be up for hacking together a port. Like I said, Libcloud fundamentally is not a lot of code. It's the difficulty in it is dealing with all those providers who have their perverse way of describing what a server looks like. And once you've written that once, porting it to another language is actually a lot easier because you actually have like test cases, examples of what the output of the API should be. So you can actually make it, you can build a second language like in JavaScript much quicker. And that's how the Java version of Libcloud is going, is they say, well, we can look at exactly how the Python is parsing this and say, okay, let's port that to Java. It's much quicker than the original port where, it's a lot of research, even like, Amazon is very well documented, but they even then, they don't necessarily have examples of all the responses you get back. There's a lot of weird data, and especially in like Rackspace's API, it's very different than, although it's better documented than it was, but a lot of the APIs are lacking in-depth documentation. So yeah, I would totally be up for doing it in JavaScript though.
Either from your work on the cloud or Apache, have you talked to these providers about standardizing their API?
So yeah, the question is more about standardization. We have. When CloudKick started, we wanted to do basically a dashboard across all of the different clouds. And we were very interested in trying to get cloud standardization of APIs to move forward. And we worked on that for months, and what we found is a lot of hosting providers are not tech companies. They're hosters, and they've been that way for 10 years, and they're good at running low-margin, building out data centers and running servers. They're not good at building APIs. They're not good at having large technical teams. Amazon's the exception in that, is that they have a large technical team. But they built that for a different purpose. They didn't build it for EC2. And even then, they're not very communicative about anything, because they're the market leaders, so they don't really care about standardization. They should then just use the Amazon API, right? So Libcloud is actually the result of the failure to standardize, right? I would love a standardized API, but it's just not going to happen anytime quickly. People have tried, and they've tried to create these, big working groups of companies to try to create a standardized API. And VMware, for example, has pushed this and tried to get people to do this, but it's just not been successful in the market. And so Libcloud was written because as CloudKick, we wanted to do that ability, and we needed something to do it, so we built Libcloud to talk to all of them. So yeah, it's a reaction to the lack of standardization. And some people have even said now in some blog posts that, well, we don't really need standardization because there's enough libraries like Libcloud, even in other languages, that the value of standardization is decreasing over what would have been a year or two ago. So,
sort of re-asking that question from a different direction. If Libcloud is the Esperanto of cloud, if somebody's building a private cloud in the basement of their university, or you run a cloud and you'd like to attract, if I'd like to get on your slide, is there a reference API in the middle that you can run on your gang of VMware?
So, as a simple example, we support like Eucalyptus, right, which has its own API. It's essentially Amazon's, and that works in Libcloud. As far as reference goes, there's work ongoing. I'm not sure if you're familiar with OpenStack. It's the NASA and Rackspace's kind of open source implementation of Zen all the management layer across your VMs. They're actually going to adopt the Rackspace API or something very similar to the Rackspace API with a few modifications. And I would say that's kind of the emerging standard of where more and more people are moving to. Because at least there's an open source implementation of it that's not insane like Eucalyptus. And Eucalyptus I would rightfully call insane. So that's where it's kind of going. Having said that, most APIs, as long as they return valid XML or valid JSON, there really isn't very much libcloud code to make it work. As long as they have the same basic concepts of, creating a node, listing your available images, all those basic concepts, most APIs have that. So, I wouldn't be afraid if if you're building something, you can just come submit a patch for what you have, and it's not a big deal. Okay, anything else? Okay, thank you.